Hello and welcome to the Essential Basics Guide for nDisplay Setup in Unreal Engine 5.6. This video is going to go through every step from start to finish on setting up an nDisplay configuration with either an LED wall or a TV, depending on your use case. And right beneath me, you will see there is a document which will be linked in the description, so you are able to follow along with me. Here are the steps we're going to be going through. We're going to be creating the project, we're going to be configuring the file, we're going to be setting up the screen, we're going to be setting up cluster nodes, the camera, we're going to be setting up Switchboard, camera tracking, and also going through a couple of common settings. For this video, it is worth noting that the camera tracking will consist of Unreal Engine's VCam app, which is free. If you're using a different type of camera tracking, this will mean that your setup will slightly vary, so please be aware of that as we're going through the video. Step 1, we need to create our project file. So as we can see here, I have my Unreal Engine project browser open. My first step is going to be going down to the Film, Video and Live Events tab and clicking on the nDisplay template. Here I'm going to name it whatever I want. So for this, it's going to be nDisplay Basics Video. And then we're going to click Create. And while that's creating, I just want to point out that in 5.7 and beyond, the UI has changed for the creation of these template files. So that is something to be aware of when you are creating projects in 5.7 and forward. But as this video is for 5.6, we'll be focusing on the UI style of 5.6. I'll be back when the file is created. So here we have our blank brand new project ready and open to be able to be used. The first thing that I encourage people to do here is to clear a little bit of the area out. So at the moment you can see that we have a ton of things in the outliner that we might not necessarily need, and especially when it comes to setting things later on, it might get a bit crowded. So I'm going to do is just quickly select some things that are out of the area that I might not need or want in the area. So we should be left with something that looks like this. Something that we can easily have a bit of depth with and something which has a few things that could be useful. I'm just going to take this one step further, and I'm going to just put a couple of folders together where I'm going to put my environment aspects, another one where I'm going to call it props. I always find it's a good practice to get into having these folders set up, because when you have a larger file and you have a lot more assets in, it's quite hard to be able to find things. So it's easier to start this process from the beginning rather than later down the line. We also have currently the nDisplay Basics config, which is already created by Unreal in the template. For now, we're going to delete that from the world just to make things a bit easier, and we're also just going to click Save to make sure everything is saved. Before I go any further, I do want to make clear that this tutorial is going from the absolute basics of not having an nDisplay config at all. If you're operating in a studio which already has an nDisplay config file, you don't need to go from this template stage. You can use whichever Unreal Engine project you want and import your nDisplay config into that. That'll make sense a bit later on once we go through and we have created our nDisplay config. Our first step, as you'll see, I'm going to be using the document which is currently beneath me. So I'm going to scroll on down to the next page where we have creating the next config file. Our next step is to create our own nDisplay config file. So what we're going to do for that is we're going to go into the example configs folder. And here we can see there are multiple different types of nDisplay config that are already created for us to be able to use. We have basics, cave, unwrap, dual wrap windows, dual monitor, multi-view ports, curved wall, and an XR stage. For this tutorial, we're just going to go very simple. We're going to copy the nDisplay basics. So I'm going to right click, duplicate, and I'm going to call this nDisplay basic video. And I'm just going to show it saved. Then what we need to do is we need to drag this into our environment so we have it there. Once we've dragged it in, we should have something like this, where we have our nDisplay basics video config there, and we have our file down here. So the next step obviously is to click on it. So we've opened it up. I'm going to pin this over here so we have it pinned into a open tab. And one thing that I find quite useful across both configs and also blueprints is to go to compile and where it says save and compile, I want to change that to always. So instead of having to click save and compile, I can just click compile and it will automatically save for me, something which has saved me a lot of time. The next step is to set up the nDisplay screen. For this video, we are going to assume that we are using our monitor, but there are cases where you would want to do dual screens. This is something which the document below covers, and is something which, if you are going to be using, I recommend going and having a look at the document. Going from left to right, we have our components of our nDisplay config, we have our viewport, we have our details panel, we have our cluster nodes, and we have our output mapping. If you've used media servers before, you might recognize output mappings. This can be found in such things as Disguise, where you would have a video feed that you map out to whatever display outputs you have. In our case, we're just going to be acting as if we have a HDMI out. First thing that we want to do is we want to make sure that this pre-existing screen is the correct size for what we're wanting to display on. And for our instance, we're going to be displaying on our monitor. So the first step would be to take something like a ruler or a tape measure, and we would want to measure the physical width and physical height of the display portion of our monitor. This doesn't include any bezels, so if you have a bezel on your monitor, do not include that in your measurements. Once you've got those measurements, you want to click on your nDisplay screen, you want to go over to the details panel and go down to size. In this section of the nDisplay config, size will always be in centimeters. This is not something that is always universal though, as you will see later. There are parts where size will actually be in pixels. So there's something to be aware of and something that I will point out later. Something else to point out is the aspect ratio preset above the size of the screens. At the moment, and by default, it will be set to 16:9, as that is the standard for monitors and TVs. If your display is 16:10, as my laptop monitor is, or if you have a different ratio due to using a LED wall, for example, then you would need to come down and either choose your ratio if it already exists there, and if not, you would simply just click the unlock button and then start changing your X and Y size, and then the aspect ratio preset will turn to custom. If you're using something such as a curved LED wall, however, then what you will need to do is not use an nDisplay screen component, you will need to use a mesh instead. And this mesh will need to be metrically correct to the real-life counterpart of which it is representing. That is to say, if you have an LED wall that is, say, 10 foot tall, and it is 10 foot wide, but has a 30-degree curve around it, you need to make sure that your 3D model, be it made in Blender or Inventor or any other software, you need to make sure that that model is in the correct scale, with the correct units, so that would be the correct width, the correct height, and the correct curvature, and then make sure that when you import it into Unreal, those units and measurements stay the same. And you would delete the nDisplay screen and replace it with a mesh as according. However, as stated, we're going to be using our monitor for today, therefore we can stay with our 16:9, and for the moment I will leave my size 200 and size 112, as it doesn't necessarily matter for me. Our next most important thing to do with the screen is to make sure that it is in the correct position for our acting space. Now I'm going to give two examples here of where this might change, and I'm also going to demonstrate one of them. As we can see, we have the center of our screen as denoted by the 00 point of our viewport. Our display is back by a meter, and it is also sunk into the floor. Now what we need to do is measure the location of our screen in the physical world in relation to the center of our acting space in the real world. So for me, that will be the center beneath my chair, and then my monitor will be here off to the side. So I would measure up from that center point, I would measure forwards, and I would measure out sideways, and then I would make sure to move my display around with the units over to the side with the transform location, and I would maybe take it off snapping and make sure that I have matched the movement exactly. That's what you would want to do if you're using your monitor or TV in your room or anything else like that that is not normally situated. However, if you're working in a studio with an LED wall or something similar, the acting space might not necessarily be in the place that you think it is. What we'll do for this video is we will assume that the origin center point of our acting space is also the same as where our tracking is. This will become important later. In a virtual production studio, these could potentially be in the same place, but sometimes they can be in different locations depending on what type of tracking software you're using and also the setup of the actual individual space itself. For this video, we will go with the premise that where our origin point of our space is going to be the center bottom of our LED wall, which is a common setup for virtual production studios. So I'm just going to quickly take this off snapping. I'm going to move it down. I'm going to make sure that we are exactly in the right spot. An easy way to make sure you have the correct height of the wall up from the floor is to take the Y height of our wall and put it in to the box and divide it by 2. And this will give us a perfect offset from the floor. I want to make sure the others are 0, so we are centered easily. This is important for later steps with the camera tracking, where we have offsets and things that we need to take into consideration when we are calculating things. The next step of the setup is to make sure that our cluster nodes are set up correctly. So what we need to do is go down to the bottom left where we have our cluster nodes listed, and they are organized by cluster, device, then render node within that device, and then the actual viewport that we are rendering, or the view or render viewer, whichever phrase you want to use, but it is the visual of what we are rendering. If we are rendering on the actual machine which are running nDisplay on, this editor instance, what we will want to make sure is that our IP for the device we are rendering on is 127.0.0.1. As we can see here on the top right and over here. The way we set this, as you might notice in the details panel, we can, is we go into our node and we set our host IP address. If we were rendering on a remote node, let's say we are in a virtual production studio that has 3 render nodes, then what we would want to do is make sure that we have 3 nodes and each of them has a different IP, and that IP address is the IP address of the machine that we are wanting to render that node on. It is also worth noting at this point that to do that you will need to have Unreal Engine and Switchboard, which we'll talk about later, both set up and installed on those machines and configured as per the later instructions in the document, as well as making sure that the project file we are working on currently has also been free file synced or sent over through Perforce or whatever revision management system you're using for your project. The next step is to make sure that our output for our render node is set to the correct pixel resolution. This is where we make sure that if we have a HDMI output or a DisplayPort output that is either 4K or 2K or 1K at max resolution, what we want to do is go to our window and we want to set our size to whatever we want our size to be. This is very important when you are dealing with things such as LED walls, where the actual pixel resolution of segments of walls or entire walls isn't necessarily going to be a standard such as 1920 by 1080. It might be very unique and might require specific numbers of pixels to be outputted so that when it is mapped in your LED processor, it appears correctly on the wall. Here we can also set our offset position. What this means is that, let's say we have a mapping setup that isn't necessarily the most normal, we can set our output to be displayed as an offset on our output. 2 things that you need to look at as well in the configuration is enable sound and full screen. I recommend disabling enable sound and making sure that full screen is enabled, as this is something which is important if you are rendering on external nodes. You don't want sound to be coming from devices that don't want to be producing sound, and you also want to make sure that there aren't any pop-ups or other things such as the mouse cursor that could somehow randomly appear on your LED wall, for example, on a volume set. On top of that, if you're working on something such as an LED volume set where the render nodes might have multiple monitor outputs, or if you're working on your laptop or home desktop and have multiple displays, what you might find is that you'll go onto here and you'll try and display, and it will start displaying from your primary monitor. With the way that Unreal Engine and Display is designed, it will always start displaying on the primary monitor from the top left pixel outwards. Let's say you have a monitor on the left-hand side and a monitor on the right-hand side, and your primary monitor is on the left. What we'll see is that the display, it starts on the top left of our left-hand monitor and goes out 1920 and down 1080 and has the full image displayed there. But let's say we want it displayed on our right-hand monitor. We can't simply just drag it across. So the way that we solve this is we go to our node, we go to our window, and we go to position. Here, I can set an offset. So let's say I have 2 1080p monitors side by side. and I want my display on the right-hand 1080p monitor. What I will then do is I will set an offset of 1920 there, so that when we start displaying, we will end up displaying on our second monitor. If you have a monitor that is a different resolution, or you want to be displaying on different heights or widths or a different offset, then you can add that in on your node and add whatever offset you need in these two boxes. Our next step is to make sure that our projection policies are set up correctly for every render node that we are using. This is more important when you are working with an LED wall and less important when you are working with a monitor, but it is still good practice to do both. So to do this, we go to our viewport at the bottom there, put viewport 0, we go over to our projection policy and we change it from type simple to mesh, and then we go down to our drop down for mesh and we choose our nDisplay screen. The meshes will be pre-populated with whatever type of mesh is in our components, and as we have a nDisplay screen called nDisplay screen, that is what we've selected. Going back to what I mentioned earlier to do with having a metrically correct mesh for your LED wall, but let's say it's a curved one. This is where you would have your mesh put into the left side over here as a component, and then in this viewport bit at the bottom right, you would then select in the mesh option your static mesh that you have for your LED wall on the left hand side. Therefore, it would project correctly for the camera as if that curved wall was a flat portal into the Unreal Engine world. That is to say, you would not end up with any perspective distortions from the curvature of the wall. If you are using a dual monitor setup for your nDisplay output, what I would recommend is having a look at the document in the description below. As you can see beneath me, there is a page here specifically responding to the idea about outputting to two displays at the same time. The document also explains how to make multiple screens and make sure that they are the correct ratio in both the output and in the viewport so that you don't get any stretching or squishing from different sized outputs. Let's say we are on an LED wall and we want to add another render node. We will go over to our cluster, we'll click add, we will click add new cluster node, and here on this menu we would name it however we want to name it. So I'm going to call it my nDisplay basics video node. We want our parent, and we're just going to put it in the normal cluster parent. If we want, we can use a preset. We can go from SD all the way up to 8K. For now, I'm just going to leave it at full HD. What we also want to do is make sure that we change our host IP address to be correct if we are using an external device to render. This is again where we will make sure that we take the IP address from the render node that we are rendering it on, not our current device. This is also a good It's also a good time to point out that all devices on a network running nDisplay should be on static IP addresses so that the IP addresses do not change after you have created your nDisplay config. Again, I'm going to use the same settings as before, enabling full screen, making sure we have everything else set up correctly there, and then we are going to click add. You should see now we have another output set up. And as the cluster nodes both have the same IP address, both being local, they appear on the same display out. If we want to change this, I can simply just go up to the top right, and I'm just going to change this to number 2. And we can now see that we now have two different render nodes on two different machines. As you can see, one is called host 0 and one is called host 1, denoted by the machine icons. You want to repeat this process for every single nDisplay node that you have that you are wanting to render on. Our next step is to set up the camera. This isn't the last time we will come back to our nDisplay config, so don't close it, but this is the next step. So what we're going to do is go back into our main level. We're going to go down to our actors, to cinematic, and add Cine Camera Actor. I'm going to name my Cine Camera Actor appropriately, so I'm going to call mine the nDisplay Basics Video Camera, and then we want to make sure this is zeroed. We want to child it to our nDisplay config that we added into the world earlier, and we want to make sure double check to make sure it's zeroed again, and there we have it. This is where we have two important bits of information though that you need to understand. The first is tracking. So if we're using a tracking system that has a additive offset for our tracking position, we want to make sure that our camera as a child of our nDisplay config is at 000 on both location and rotation. If we are using a tracking system that isn't additive and takes whatever point it starts at as 00, such as Unreal VCam, what we can do is we can move our camera back a certain amount and have it where we would want to start it. So in this case, if I always knew that my camera was always going to start facing the center of the wall from 2 meters back, 2 meters up, I would go into my location and I would make sure to set 2 meters back, 2 meters up. For now though, for this video, I'm just going to set it far enough back that we're able to see our nDisplay config, just so that we can actually see what we're working with. And I'm actually going to just push it in a little bit more, just so that when we have our inner frustum appear, we know that it's working, as we'll be able to see it. I'm going to save everything. We will come back and change some of the camera settings later on, such as setting up the tracking, but for now, we need to go back into our nDisplay config. Now what we want to do back in our nDisplay config is we want to go to add, we want to go down and add an ICVFX camera. For now, I'm just going to leave it named ICVFX camera. I'm just going to make sure we compile and save again. I'm going to click on our camera. I'm going to go to our details panel, and at the bottom where it says camera section, Cine Camera Actor, I'm going to click down and I'm going to find our Cine Camera Actor that is attached to our nDisplay config from our level. What this will do is it will take the position, rotation, and other information from our Cine Camera ND level and apply it to our nDisplay config within here, to our ICVFX camera, should I say. So what you can see is now we have this inside square appear on our nDisplay config display. If I go back to the outside, what you now see is the perspective has changed on our viewport of the camera, and we can now see this inner frustum is now on this display here. What this is telling us is that the position and perspective of our Cine camera is being accurately used and represented. You can see as well there is no box on the outside of our camera view, which means that our inner frustum is at the correct size. Depending on how fast you move your camera across your nDisplay config, you might need to increase the size of your inner frustum as to compensate for the lag generated by the latency from frame generation within a virtual production setup. At this point, most of the basics that we would need to set up for an nDisplay config have now been done. So the next step is to make sure that we have Switchboard set up. So what you need to do is you need to make sure that you go to the plugins folder and you want to make sure that Switchboard is enabled. Switchboard being a beta plugin, you will need to restart your environment when you click to enable this. What I would also recommend setting up whilst you are here is virtual memory. This is to make sure that when you're using Unreal Engine VCam, you are able to access that data. Once again, this will pop up and say that you need to restart. So we don't want to click that just yet because there is one more plugin that we do want to double check is enabled, just like Switchboard. In the nDisplay template file, it should also automatically be enabled by default. This other plugin that we want to enable is Pixel Streaming. In some cases, pixel streaming is either disabled by default or has been actively disabled, depending on what workflow you are using. An example of this is that sometimes pixel streaming will cause red text error messages to appear on a render stream workflow with disguise. Therefore, you would disable it in the Unreal Engine project. So if we're using nDisplay, we do need it set up, especially when we're using VCam. So I'm just going to click restart and I'll be back once our project has restarted with both of these plugins now enabled. Once our project has been restarted, what we should find at the top of the screen is we now have a pixel streaming option and we now have a Switchboard option. For our pixel streaming, what we can see when we click on it is we have a streaming port, a viewer port, we can launch our signaling server, and then a bunch of other settings. For this tutorial, all you need to know and look at is the signaling server, which we'll come to when we look at the tracking. For now though, we need to make our nDisplay config for our Switchboard. Switchboard being the program that Unreal has created, which allows us to remotely launch both multi-user and our nDisplay render nodes without having to manually do it on every single machine. If this is the first time that Switchboard has been launched on a machine, what you'll find is that the Switchboard listener to work, which is the client side of our client-server architecture with Switchboard, you will need to both launch and create a password with Switchboard listener before it will work. And without it working, our nDisplay setup won't work. So what you want to do first is you want to go and click Launch Switchboard Listener after clicking the three dots next to our switchboard icon. What you'll find is that you'll have to go through an install process for the switchboard listener. Unfortunately, I didn't record this. However, I do have screenshots from the process, which are both in the document and I will now be throwing them up on screen. You want to make sure that the option of Launch Switchboard Listener on Login is enabled if this is a render node that you want to be able to remotely access and start things from in such instances as an LED volume. Once you've gone through most of the process for setting up Switchboard Listener, you should be greeted with a prompt that asks you for a password with it. This is where you just need to create a simple password that you will be able to remember and be able to use in future. And if these machines will be used in a public setting, i.e. a virtual production studio where you might have different operators come, don't use a sensitive password of your own. Make sure you use something that is memorable and easy to write down for other people to use at a later date. This is also a password that you will be required to put into Switchboard itself when you are trying to access the Switchboard listener on a remote computer. Once that's done, what you'll find is that Switchboard will now launch, and Switchboard should look something like this. What we'll find is it will say status not connected. What that means is that our switchboard listener is not connected to a switchboard, which is correct because we haven't launched one yet. So now what we will do is we'll just close switchboard listener for the moment. I'm going to click on create config. This is the config file for Switchboard, which tells it what project level, node structure, camera structure, and every other bit of information that will be required to launch an nDisplay config through Switchboard remotely. So I'm going to call this our nDisplay basic video config. And here we can choose our nDisplay actor. Here we can see there is only one. And as you might notice at the bottom in the content drawer, we actually have a fair few configs. But the reason we only see one of them is that the Switchboard config options only allow you to select an nDisplay config that is in the outliner as part of the level of the world that you're creating. If we want to have multiple multi-user editors being able to edit our nDisplay config at the same time during a shoot, let's say we have someone who is just editing the nDisplay config and one who is a VAD artist editing our background environment, what we want to do is make sure that we increase the number of editors to 2. As I'm just doing this myself, I'm just going to keep this at 1. Once we've done all that, we can then click OK. And what we'll then find is a couple of windows should appear and then close. And that will show us that our nDisplay config has been created. Now that our config has been created, the next step is to wait for the switchboard listener to open. On the first time that you do this, it might take a while, but as you go along, you'll find that it will get a little bit quicker. So we can see here now, if I just move these side by side, is we have switchboard and we have our switchboard listener. In Switchboard, if we want to find our configs, let's say you're wanting to change to a different config for a different project, or you've not just created the config as we have done, where it would preload as it has done for us, we'll want to click on configs, click on load config, and then we would see options which are in the specified folder, which when we click browse will be taken to. You can see here is the location. They are all stored in JSON files as per a lot of Unreal Engine's methodology for file storage, and these can also be copied across devices. What you'll also notice is that in our load config, NBV is actually grayed out. This is because it is currently loaded, so there's no point trying to load it again. What we can do is we can see 2 of the ones that I have created from previous instances. We can also create save a new config, or we can create one entirely new from scratch. Or we can even delete our current config if you want. If you want more information on how to launch Switchboard, what you'll be able to do is find this information in the document beneath as well, as there are multiple ways of launching Switchboard, such as the one already shown, and also finding it through the Windows menu by simply typing in Windows key and searching the word switchboard. Now we're going to go through the switchboard itself. What we will find here is at the top of the switchboard, we have a representation of our tape recorder. Just like we have our tape recorder within the Unreal Engine editor, this is an accessible form of the tape recorder found in Switchboard. Here we can name our sequence, we can name our slate, we can auto increment our takes, and then we have a big red button to click record with. Beneath that, we have the left section, which will contain all our Unreal Engine editor nodes, our render nodes, and all our settings to do with levels and other devices. On the right hand side, we have our monitoring system, where we can see a log, and we can also have all the information about the nDisplay machines and instances that we are connected to. At the very bottom, what you'll find is we have multi-user server. So, as I mentioned earlier, if you have multi-user people set up to be able to edit the environment in real time, you would normally, in a render stream process, set up multi-user yourself, either within Disguise or within Unreal Engine, and launch that separately when you're launching your render stream projects. However, because of how Switchboard is part of Unreal Engine, we are not only just able to create a multi-user server through Switchboard, we are also able to auto-increment the number on the active session that we are joining, or we are forcing all the nDisplay nodes to join. This works really well when you are in a shoot and you want to have a quick save state for changes that have been made on the fly during the filming and shooting process. Or let's say you get to the end of the day and you want to just very quickly save things, you can have the session for, say, Monday be archived and come in on Tuesday and continue with a new session. This will allow you to roll back to Monday's archived session without losing too many changes. In our devices section, the most important things to know are the level and the lines of buttons on the right hand side. So what we'll find is any level which has an nDisplay config file in, or more specifically, our nDisplay config file in, will be listed on here. At the moment, we've only got one, which is main, and we can see at the top here in our Unreal Engine environment that it is also called main. If we had updated this through Perforce or something else, we can click sync and we can recheck to see if there is a new level available for us to use. Beneath that, on the right hand side, we have a bunch of plugs that are not connected to anything. These buttons are all representations of whether or not you are connected to that device or not. If I click the topmost one, it will make Switchboard reach out to every single device, both editor and nDisplay render node, and it will try and connect to all of them. And if I click on the top of either of the black two, it will only do their respective blocks, that being Unreal Engine editors and Unreal Engine nDisplay devices or render nodes. So if I click on that, what you'll see is a bunch of things will happen in the log, and we will see on our Switchboard listener that we are now connected to our machine. Once again, showing our IP addresses as listed here and listed onto the side. Also find there are errors as I haven't set a VP roles file, though that doesn't stop the functionality of Switchboard. What I also find is our nDisplay monitor has now come alive as we are now connected. So we are able to see the mosaics, which is our outputs that we have set. We're also able to see our CPU utilization, our memory utilization, and we will be able to see our GPU utilization and temperature too. This is a good way of monitoring the temperatures, utilizations, and various other telemetric data for our different nodes that we are connected to. Let's say we are working on a large scene and we suddenly encounter some stuttering. It's a very easy check to be able to just scroll along and see if we are bottlenecked on our CPU or our GPU, or see if our computer is overheating or if we have run out of RAM. That way we know whether or not there is an issue with the environment or the machine that we are using. And then that'll give us better information to make informed decisions on set in real time. You'll also notice that everything else on the left hand side has now come alive with being lit up blue, and everything that was previously grayed out is now ungrayed. So our second row of options, our boxed arrows, are specifically for launching things. If I click the topmost, it will launch the Unreal editors with multi-user, and it will launch our nDisplay devices. And when it means devices again, this means the render node. Before I click them, I also want to explain the one to the left of them, which is for multi-user. So let's say we don't want our render nodes that will be displaying on our LED wall to connect to our multi-user server, we can actually turn that off by simply clicking the person icon and graying it out. This could be quite useful if you, say, are wanting to still edit the environments on multi-user editor stations, but don't want that to be reflected on the wall and don't want that to be impacted if say some people are still filming on the wall, or you might just want things to run as they currently were without any multi-user updates. I'm just going to enable that again to make sure that we're fine. You will also notice on every change we also have a new line appear and it will tell us what has happened, which is a good way of being able to keep track of any changes within the switchboard or multi-user process that we might not be aware of. To demonstrate how this works, I'm actually just going to quickly close our Unreal Engine editor there, and I'm just going to now launch our Unreal Engine device there. What we'll be able to see is our multi-user server has now actually launched, as you can see there. And we can see that auto-join has been enabled, our session has been created. You'll be able to see that our Unreal Engine project is now opening. And once the shaders have been compiled, I'll come back. Now that our editor is open, what we'll be able to do is go to our window, go to multi-user browser, and if I just drag this out over here, be able to see that we are connected to mu-nbv-1. If I go across to our switchboard, what we'll be able to see is our session is called mu-nbv-1. This shows that our multi-user server is working correctly and that our switchboard is working as intended. Now, as the last step, what we need to do, we need to set up tracking for our camera. So for this, I'm going to be using VCam as it is free, and that means it is accessible for everyone. To do this, I'm going to make sure that I have the live link window open. So I'm going to go to Window, I'm going to go to Virtual Production, and I'm going to click on Live Link. What I then need to do is go to Pixel Streaming, and when I click on it, I'm going to just change the viewer port from 80 to 1111. The reason for this is sometimes I have issues trying to connect my VCam on port 80, therefore I try 111, and this is something that I've heard from a lot of people that works quite reliably. What I'm then going to do is launch my signaling server. You should see that obviously nothing apparent happens, but when I click on Pixel Streaming, we should get a local IP address and a network IP address for our device, and we should have the port 1111 at the end. This is where you want to note the IP address down, as this is what we will need to connect our phone with on the VCam app. But for now, what I need to do is I'm going to go to my camera component, I'm going to go to Add, and I'm going to find my VCam actor. This again is here because we enabled the virtual camera plugin earlier on. If you haven't done so already, please do that now. But once you've added this, what you'll now notice is that we should have some new settings. And in these settings of virtual camera, we want to go down to output providers, we want to click on the add element, and on the drop down, we want to click pixel streaming provider. We want to make sure that this is active, and we want to make sure that enable ARKit tracking is ticked. This is the tracking from our VCam app. What you'll also notice now as well is that in our live link we have pixel streaming, we have a streamer ID set up with our camera, telling us that our camera is now ready to go on VCam. So what you need to do is then get your phone, you need to open up the VCam app, and on Unreal Engine VCam, what you should see is you should have a bunch of options. As we set our port to 11111, if this is the first time that you are connecting VCam to this session with this IP address, you need to click on the bottom left where it says New Unreal Engine Connection, and then you need to put in the IP address of your signaling server, which is there. So for me, that is 192.168.1.182, and then in our ports, I need to put 1111. Obviously, the IP address will be different for yourselves, and also if you are coming back to this after you've turned your device on and off, you might have a new IP address, so you need to make sure that you check and input the right one. Also, the reason why we can't just necessarily click the option on the right hand side is that you will notice that that says port 80, but we have now changed our port to 11111. You're welcome to try with port 80, but as I say, I have had issues with it, so in the interest of saving you guys time, I would recommend just sticking with port 11111 and just taking the extra 2 seconds to input this manually. And then what we should see is once I click connect, it should take a moment and then it should just go straight through. Okay, so after just a couple of seconds of checking, I realized I actually inputted a wrong digit in my IP address. So I'm just going to try and connect again. What you should see now is if I unclick here, as I move my camera around, we now have VCam working. And as you might be able to tell through here is that it is actually quite responsive. The delay on here is, I would argue, similar to a lot of tracking systems that you would find. Is it accurate enough to be able to be used in a production setting? Probably not, especially due to the fact that if I say disconnect from the app, what you'll notice is the camera stays where it is, but if I now reconnect, the camera will snap back, but it takes whatever position I have as forward. So I face my phone to you guys, and I go away. If I now turn it sideways and click on my connection, you'll see forwards is now off to the side. This is not obviously useful when you're doing professional setups, but especially when you're wanting to test stuff at home, or if you're a student or an education establishment, this is more than apt for those scenarios. And with that, we have all the basics set up for our nDisplay configuration. Another couple of things that we are going to have a look at though is a couple of common settings that are usually changed and needed within our nDisplay configuration. So our first common setting to change is whether or not the outer frustum of our display is frozen or not. It's quite common on a film set that you'll want the outer frustum to be frozen so that you're not using as much resource draw when you're not getting any benefit from it if it's not a scene that requires indirect lighting or reflections that update every single frame. So to do this, we want to go to the root of our nDisplay config, and in our details panel, let's come down to our viewports, and we want to click on freeze viewports. And with that, our outer frustum will now be freezed. The second most common set of settings that you would want to change are the settings for your inner frustum. To do this, you want to go to your ICVFX camera, and then here you will have a bunch of inner frustum settings. Primarily, you can change the soft edge, whether or not you have a feathered edge around your inner frustum. You can change the overscan, which relates to the size of the inner frustum. So going back to what I mentioned earlier, if you have a lot of delay and you are now starting to see the edges of your inner frustum as you're moving around, you might change your overscan multiplier to 1.2 or 1.6. It is quite common in disguise that you would maybe have it at 1.2 or 1.6. But obviously in our current setup we can leave it at 1. You'll also find various other bits such as rotation and offset. Let's say your tracking point is not directly at the nodal point of your camera. This is where you'll be able to set things up to align it so that it does look like it is all correct. Beneath that you will also find more settings for your camera as well, and then color grading. But anyway, with that, that concludes the video of the Essential Basics Guide to Unreal Engine nDisplay. I hope this has helped. If you have any further questions, feel free to reach out, and also have a look at some great communities such as Starting Pixel, which are a great resource of people to be able to have discussions and ask questions that relate to virtual production and with things within the industry. Thank you, and see you next time.